Section 10.0 Real Numbers. Essential question. How do you classify numbers? So what we're going to do in this lesson is look at all kinds of different numbers and classify them into different groups. So there are quite a few vocab words that you are going to need to make sure you get written down in this lesson today. So make sure you're writing down everything that I do next to each vocab word. Okay, so we're going to start with what natural numbers are. Natural numbers are just counting numbers. So if you think about when you learned to count when you were little, when you learn how to count, you start with the number 1. So starting with the number 1, 2, 3, 4, and so on. Those are natural numbers. Those are our counting numbers. Whole numbers. Whole numbers add in one extra number that natural numbers don't include. And I like to highlight the O in whole to help me remember that 0 is the number that gets added into whole numbers. So whole numbers starting with our 0, then 1, 2, 3, 4, and so on. So once again, that 0 is the only number that is a whole number that isn't also a natural number. Integers are positive numbers and their opposites. So for example, the opposite of 2 is negative 2. The opposite of 3 is negative 3. The opposite of 4 is negative 4. You can also think of it as numbers on a number line. So some examples are negative 3, negative 2, negative 1, 0, 1, 2, and so on. So positive numbers and their opposites, also known as numbers on a number line. Now you'll notice that a lot of these numbers are getting repeated and are in more than one group. So for example, the number 1 is a natural number and a whole number and an integer. So numbers can fall into more than one category. The number 0 is a whole number and an integer. So they can fall into more than one category. All right, rational numbers. So there's going to be a bunch to write for rational numbers. So I'm going to move these down for a second here. So rational numbers, all rational numbers can be written as a fraction. So then I'll give you lots of examples here. So one example is integers. So integers can all be written as fractions, so they are rational. So all of that list of negative 3, negative 2, negative 1, 0, 1, 2, and so on. All of those are integers. What else is an integer? Terminating and repeating decimals. So I'll give you an example of both of those. So a terminating decimal would be like 0.25, meaning it stops. Repeating decimals usually have that little line above it. So like 0.5 with that line above it means it's repeating. Or you might have something that's just 0.222 with the dot, dot, dot at the end. That also means that it is repeating. Other things that are rational are perfect square roots. So for example, the square root of 36 is 6. So that's a perfect square root. And then obviously fractions. I'll still write that even though we already have up there earlier, can be written as a fraction. But I'll still put fractions in here. So anything like 4 over 5 or 1 1/2. So it could be mixed. any kind of fraction. So rational numbers definitely has the most numbers that would fall into that category. There are a lot of different things that can fall under the rational category. Irrational numbers are the opposite of rational, where they cannot be written as a fraction. So the most common irrational is pi. It's also non-perfect square roots. So I'll do like this, square root of 17, for example. And then non-repeating, non-terminating decimals. So that means a decimal that doesn't stop and doesn't repeat. So like 2.1741336 ... No repeating and no and it keeps going forever. So pi, if you know pi is 3.14159. It keeps going forever, never stops, never repeats. And then like the square root of 17 keeps going forever, never stops, never repeats. And if it helps you, you can kind of do this. You might want to do this in your notes to know where each vocab word stops, because there's a lot going on with all of these. Okay. One more is real numbers. So real numbers is really, up until this point, any number you've ever learned in one of your math classes. So it's all rational and irrational numbers. So all rational and irrational numbers are considered real numbers. They're part of our real number system. All right, now you're going to notice as I go to the next slide, I'm going to refer back to this slide a lot. We're going to take actual numbers and categorize them. So I'm going to go back to my vocab frequently in order to figure out what category a number should go under. All right, so you are going to see a big diagram with the real number system. So what I want you to do is on the right-hand side of your notes, make a big rectangle, and you're going to write the word real in the upper left-hand corner. And that's because the entire number system is the real number system. Then our two groups within the real number system are irrational, so make a circle for irrational, and rational, so make an oval for rational. Or a big circle as well. Then, within rational, there are three other groups: integer, whole, and natural. You may have made something like this in 7th grade last year because you do the real number system in 7th grade as well. Okay, so now once your grid is made, we are going to take all of these numbers on the bottom and bring them to a spot in our real number system. So this is where I'm going to go back and forth a lot from your vocab to help us figure out where a number should go. So I'm going to start on the far left with 0.3 repeating. So that is a repeating decimal. So what I'm going to do is go back a slide and find out where did I write down repeating decimals. I'm going to do some highlighting each time I find that. So look for the word repeating decimals, which is right here. That 0.3 repeating is just like that 0.5 repeating, and that fell under the rational number category. So I am going to take this 0.3 repeating and put it under the rational category. So you should write that down as well. Okay, next one is 3.5. So if I look for the fractions, the word fractions are right here. So 3.5 is just like 1.5. that also falls under the rational number category. So I'm going to bring 3.5 over to my rational number category. All right, -4. So where do I first see negative numbers? Negative numbers fall under integers because they're positive numbers and their opposites. That's where you first see negatives come into the real number system. Now keep in mind, a negative is also a rational number because you'll see the word integers under rational as well. But we're always going to put it in the innermost group. So yes, -4 is rational, but since it's an integer too, we're going to go to the innermost ring. So like I said earlier, a lot of numbers will fall under more than one category, but bring them to the innermost ring. All right, 0.35 is a decimal that stops, or a terminating decimal. So where I see terminating decimals is right here, terminating, like 0.25. So I'm going to take 0.35 and drag it to rational. All right, the number 5. So the number 5 is just a counting number. That's the first place we see just your basic numbers, counting numbers. So I am going to bring that counting number to the natural category. Again, it could go under more than one, but we want to bring it to the innermost. All right. The number 0, where did we first see the number 0? That's right there under whole numbers. Whole numbers. That's where my 0 comes into play, that O in whole. The square root of 36. Well, the square root of 36 is 6, which is a natural number. The square root of 71. There's no number times itself that makes 71. So that is going to fall under non-perfect square roots. So non-perfect square roots are irrational. 5.7 is a terminating decimal, which is rational. 15 is a counting number, so natural. 13 is a counting number, so natural. The negative square root of 25, well, the negative square root of 25 is 5, so -5. So that would fall under the integer category, because the negative square root of 25 is just -5, and negatives come in the integer row. Pi is our most common irrational. -4/5 is a fraction. Fractions are rational. Square root of 16 over the square root of 49. Well, that's rational because square root of 16 is 4. The square root of 49 is 7. So 4/7 is a fraction, therefore rational. -17 is an integer. 3.2146, let's go back a slide here to find non-repeating, non-terminating decimals. There's no repeating there and it keeps going forever. So non-repeating, non-terminating decimals that look kind of like this, that falls under irrational. Over to irrational. And then last but not least, -15.725 is a terminating decimal, so rational. So there are tons and tons and tons of other numbers you could make up and put into one of these circles or rings. So these are just a bunch of examples, but really the number of numbers you could put into this goes on forever. It's limitless. All right, last slide. Okay, so first of all, we need to talk about what a subset is. So write down, what is a subset? So a subset is a smaller group within a larger group. So while you're writing that down, I'll give you some examples. So some subgroups within CGMS are 6th grade, 7th grade, and 8th grade. The subset of Mrs. Nelson's classes are stats and MS algebra. Some subgroups within the students in our class would be the students who have a birthday in January, students who have a birthday in February, March, and so on. So any kind of group within a larger group. All right, which types of numbers are subsets of rational numbers? So what are the groups within rational numbers? So let's go back a slide and look at what groups we saw underneath the rational category. Well, we had integers, whole numbers, and natural numbers. So that's what we're going to write down. So integers, whole numbers, and natural numbers. So those are the smaller groups within rational numbers. And then last we have what are the subsets of irrational numbers. So let's go back a slide again. You won't see any circles within the irrational circle. So that means there are no subgroups of irrational. So rational has subgroups, but irrational does not. There are no subgroups, no groups within the irrational category. Summary.